Hey, welcome to another programming lecture for Python. This is going to be the first lecture where we get into a little bit more of some actual more regular coding instead of intro stuff. I'm going to take you through how to sort of what different types of data mean to a programming language, why they're sort of set up the way they are, and how to tell Python what types of data you're using. So as a little bit of a preface, I always like to go and refer back to history for programming concepts because it informs how we built the things we built and why we built them the way we did. So as I've pointed out a couple times already, the first programs that we had were punch card programs. You have little sheets of physical paper, you feed them into a machine, and when it reads where these holes and things are on the paper, it figures out that means certain commands, it means certain pieces of data, and when it would output something, it would punch holes in a card and give you an output with these punched holes. So when you wanted to store information, instead of typing it and saving it in a text file like we do now, you had to physically take this punch card and punch a hole here, punch a hole there. They meant different things, and as the punch card machine did its job, it would go top to bottom and read these lines and go across the line and say, I found a hole 3/4 of the way through the line, and there wasn't a hole after it. That means something to the punch card program. You might already recognize that has a direct analog in how our programs are read now, where it steps down and top to bottom and then left to right and gets information out. But something you might not have realized is, or maybe hadn't thought too deeply about, is that the only thing you can really store with a piece of paper and a punched hole is there a hole there or is there not, right? The only piece of information you can store is hole or no hole, which is you could equate to 1 or 0, but that would limit you at, well, you can only store a 1 or a 0. So how do you actually store more complicated stuff with that? The answer is essentially the concept of data types. If you a 1 or a 0 is what we would call a bit. It's this sort of smallest data type that we have access to. It only has 2 values. But if you start using multiple bits, you can think of fancy ways to sort of translate a few bits over to a different piece of information. It's the most caveman way that I could think to do this is, say, if you wanted to store the number 1 to 10, a single decimal number, and as we in our system only has numbers 0 to 9, and if you wanted to store a number in a really caveman way, you could say, well, I have 10 spaces here, and if I punch a hole at 0, that's a 0. If I punch a hole at the 7th space, that's a 7. And then you would just say, well, just look at 10 space chunks over and over again, and then you could store a bunch of numbers. This would be, you could have a 10 space chunk that says 7, 10 space chunk that says 8, a 10 space chunk that says 2. And in doing that, you could then store decimal numbers with just these little punched holes. That's when I say that's kind of the caveman way of doing it. There are ways that you could maybe, instead of just punching a hole at a single spot, you could do certain combinations of punched holes and not punched holes that mean a number. The one of the most common ways that you would ever learn about for doing this is called binary coded decimal, where you translate your decimal to binary, and in doing that you only technically need 4 spaces to hold a number from 0 to 10. If you want a better explanation of that, it essentially, you're just translating your number over to binary before you're storing it, which you can look up how to do if you want, and it only takes 4 binary digits to express the numbers 1 to 10. So in doing that, you've sort of compressed the amount of space that you need to store a decimal, a number from 0 to 9. But going back to our history, it's a little bit easier in some ways. It's a more direct analogy to think of after punch cards. Our next step in storage was actually magnetic tape reels. And if you've ever used a tape player, which maybe that's becoming much less common for people to have experienced, but if you've ever used a tape player, what you have is a single continuous really long reel of magnetic tape, and you read information sort of as it passes through from start to finish in a big long line. So, if you had a video, your 5 minutes of your video is going to be a certain length of continuous tape. When in a system like this, in a tape-based sort of storage system, and if you were writing a program and you wanted to store a number, say you just, when you wanted to store 52 for later, you'd have to tell your program to tell the computer to keep that information. And in order to do that, the computer needs to know, well, how much space do I need to save this information? Are you just saving a 1 or a 0? Like, are you saving a single punched hole? Are you saving a number like 0 to 9? Or, you could see naturally that the computer needs to know, are you saving a number that is 25 digits long, right? It takes a different amount of storage space for each of them, and it's actually sort of critically important that the computer knows, because if you tell the computer, well, I need to store 3 numbers on this reel of tape, and it gives you this much space, and you give it a number 0 to 9, a number 0 to 9, and then a number 0 to 9, everything is great, right? It stores those 3 numbers, it knows how much space it needs, whether that number is a 0, and it's sort of only taking the minimum amount of that allocated space, or that number is a 9, and it's taking all of that allocated space. It's okay, because it's allocated these 3 sort of slots at the right size. But if you told it you were going to store those 3 numbers, 0 to 9, and then you, in your center number, you gave it a number that is 5 decimal digits long, it can't fit that in that same storage space, right? So it would have 2 options. It could extend that storage space over top of the next one, but then you would be sort of clobbering and destroying whatever number was right here. older programming languages like C and stuff, this is actually memory management is actually one of the biggest sort of banes of these old programming languages like C. C would allow you to do this, and you could actually, if you were not paying attention to what you were doing in programming in C, you could do things like, oh, I stored a number here, and like a critical part of my operating system is right here, and now my number has overwritten part of my operating system, and you've just like destroyed your computer by not properly allocating memory. Now, given, because people are smart and C is very old, it's very hard to do that now. People have done a lot of effort to sort of prevent that from happening, but the language allows it, right? It's not it's not impossible. So that's called an overflow, for obvious reasons. But all that being said, the sort of easiest way to get around this issue is that we define data types that have meaning to the programming language and require a certain specific set of not only specific memory space for them, but also in more modern languages also have unique pre-built functions and stuff to work with them. So if you're using a number, you might have a function that's built into the programming language to round the number, or do things like that. Rounding is the most obvious example that comes to mind. And this is the basic concept of a data type, right? You'd see that like rounding makes sense if you have a decimal number, but it doesn't really make sense if you have a string of text, right? How you can't round the word character. So not only does the amount of storage matter to these types of data, these sort of associated functions and things matter to the types of data. In older programming languages, and I'd say maybe not most, a lot of languages, you define your data type when you define your variable. So you say I have a variable A, and it is a data type of this type, and its value is this. And then the programming language allocates the amount of memory that it needs for that right at the start, and it knows what's going on. Python, though, is what's called dynamically typed. A lot of people will tell you that means that Python, or I've heard before that people say that means that Python just defines everything as an object and moves on. That's not quite true. Python does have built-in data types. It tries to figure out your data type by the context of how you define it, and it's very good at converting one data type to another on the fly. So a lot of times you don't even see it happening, but it's actually, fairly important if you're doing more complex programming to know what's going on under the hood with Python. Older programming languages like C, if you didn't define your data type, your program just wouldn't run. In Python, if you don't define your data type, it tries to figure it out, and usually does. But the trade-off of that sounds more convenient, but the trade-off of that is that, lo and behold, it's not very efficient to have the programming language figure out what you want to do. Generally, things run faster if you define it all yourself, and the programming language doesn't have to invest in figuring it out, or maybe allocating a little bit extra memory just in case it's wrong, or things like that. This is why programming in C is faster than programming in Python, in essentially hardcore calculation, data analysis and things like that. So let's take, with all that sort of being said, let's take a look at how you define and use a variable in Python. Since the rest of the other courses that I've taught so far, or lectures that I've put out so far, have been all done with the command line and a little text file like these that you see on my desktop. We're going to, this is going to be the first time we're using an IDE, so we're going to switch over to PyCharm now. So what I'm going to do here on my desktop is I'm just going to make a new folder. This will keep all of our stuff in it. We're going to name it, I'm going to name it Python Teaching. Cool. First thing I'm going to do is just throw those in there. Ooh. Throw these two files in there. Weird. Oh. Windows. Always funny. There we go. I should put that right there. And then, since I have PyCharm installed and I did the option to add it to the context menu, I should have the option here to open this folder in Python Community Edition. And again, if you don't have these options, you don't have these things installed, I uploaded a video on installing, an explanation of installing PyCharm and GitHub and stuff to your desktop. So you should be able to go back and look at that and pick the same options and things I did so that these work the same way. And this is the first time I've opened PyCharm on this machine, so you should see these same things if it's the first time for you. So the first thing it's going to do is ask me if I trust this project. I am going to trust the project, trust all my projects in the desktop, and I'm going to add the IDE to the Defender exclusions list. So essentially, it's going to add PyCharm to as like an exception in the Windows firewall, so that it doesn't always have to ask if it's okay to run things. And PyCharm will normally not take this long to open. This is the initial setup, so it's doing its sort of first time load of information. Loading. You'll see down here it's doing some stuff. So once this is over, I will explain a little bit of what's going on in PyCharm if you've not seen it before. So it had some sort of failure for the Windows Defender settings. I'll have to look into that. Chances are it won't matter, but if we have issues with the code running, I'll go and investigate that. But as you can see, it's still doing stuff down here. This is all things that hopefully it should do faster in the future. It's just figuring this out for the first time. But while we wait for that, I can start to explain what's the sort of things you look for in this IDE and what they mean. So IDE is an integrated development environment. If you've watched some of the other videos, you'll notice that I did Python by opening it in a text file in Notepad, changing some lines, and then running that text file in the command line in PowerShell. And while that works for simple pieces of code, that gets quite a bit more hairy if you try to do very complicated pieces of code and you're doing things like managing multiple files or downloading external libraries and pieces of code from the internet and sort of keeping them up to date and looping them in with your code. The point of an IDE is it's supposed to kind of make that process easier by sort of referencing only the files that are relevant to your code project in this sort of window, and keeping information and things up to date on its own instead of having you do that. The other thing that's really nice about an IDE is it usually will they loop in sort of they take into account the fact that you're programming in Python. Unlike Notepad that just thinks I'm writing a text file, this knows that I'm programming in Python, and it will on the fly look at my code that I'm writing and say, knowing this is Python code, I know that this is a print statement. It's not a piece of text that means print. This is a print function. So if I, misspelt this, you can see that the IDE says, I don't know what that is anymore. But when I write print, it says, print function. I know what that is. So it helps you sort of on the fly with developing and writing code for, avoiding mistakes and making things more readable and easy to follow. That being said, PyCharm folder. I opened this folder in PyCharm. You'll see right here, this is the folder itself. It tells you where it is. You see my 2 pieces of Python code in here that are, if I open them, instead of opening in Notepad, now it opens in this nice, pretty looking window where it's highlighting my syntax and things like that. The other thing you'll see here, so I have my folder, but I also have external libraries. This is for later when we start, loading in bits and pieces of libraries that we will be using in external code. This will tell you sort of what pieces you have referenced, so you can check the version numbers or see if it's loading in the proper library. So that's that. This is taking an impressive amount of time to do this update. So I could continue this program, but I'm going to pause the video and let this update and come back when it's done, because I can run these while this is running in the background, but since this is a virtual machine, it's going to slow down quite a bit. So I'm just going to pause this and I will resume the video when that's finished. All right. That took a minute. If you're ever curious, you can go down and look at the time change on my bottom of my screen there. And so while that updated, I just brought in a nice little comment at the top of my script, and just so I have it. And then I restarted my computer so that everything would be nice and happy, like a fresh restart. But now that we have everything happy and open in PyCharm. Let's see exactly why this is useful to us, and then we can go back to talking about storing data in your in Python. So you'll see that it opened my directory. I have my little bits of code here. The other thing I'm going to do here, just right at the start, is I'm going to attach a version control. So I'm going to do this by creating a GitHub repository. We're going to select this this directory as the repository location. I'm gonna hit OK, and then oh, it might have actually attached to my account automatically. Let's see. Actually, let's. What happens if I try to do a push? Push to Python teaching. Oh, well, I can't push because I haven't committed anything. So let's commit my changes. So I just made a repository. Let's commit the changes up. So the changes are that I added these two files. I have to add a message. You have to have a message for a commit to work. Added initial files commit, and you have to choose what to commit. So I'm going to select everything. You can see there's some hidden files in here that PyCharm created so that it would make things a little bit easier for me to use this environment. You can always look up what these are if you're ever curious, but generally IDEs do a lot of under the hood work, and you don't have to worry about them unless something breaks. That advice was given to me by somebody very smart, because it bothers me to not understand the little inner workings of all these little files. And it is very easy to get distracted and bogged down in that. And it is much more powerful to just allow these tools that other people have built to help you and understand them as you need them. It's a hard thing to do for somebody who's like me, who's very detail focused. But if you allow yourself to do that, you will become a much better programmer much quicker. That's just a quick bit of advice. But so I added those to the commit. Now my local repository is going to store something on this computer, and then I'm going to have to tell it to upload that stored commit to the internet. And in order to do that, I'm going to have to log into my GitHub at some point. It might use the fact that I already logged in on my browser. We will find out in a moment. So now if I push, see, there we go. I need to define the remote repository that I want to push to. So since I don't have this repository defined, I need to create one. And this is something that you can skip if you are not interested in learning about Git. This is not explicitly Python related. but it's good to know how to do these things from a general programming point of view. So when you create a new repository in GitHub, you want to do, well, you don't need to do a template. You need to name it. I'm going to name mine the same as that folder, Python teaching. Description is optional. We don't need to. I'm going to make it public so I can share it out with y'all. I pretty much always do a README file. This is the README file in Python is what lets you, when you go to a repositories page, it's this nice little web formatted description of what's going on, where you can, add pictures and, make a nice little web page for your code. I like having them. They're convenient. Git ignore is a little file that sits in most GitHub repositories, and it tells the Git it tells GitHub what files that it doesn't need to track, because there are certain things that you don't need to keep track of. Obviously, you usually only care about your code, and they have these templates, so we know that we are doing Python, and GitHub has certain, will then ignore certain unnecessary files and that are related to Python if you choose the proper Git template. The other one that I do a lot is when I am programming in C, or when I am using Visual Studio in general, it is good to have this Visual Studio ignore, because Visual Studio makes a bunch of weird files that you don't actually need to keep track of. If you want to add a copyright license, you can do that here. I don't normally care enough to do that because I like to share my code freely. But if you're doing something that you actually care about, proprietary money things, it's good to do this right at the start. All right, so Python teaching, created my repository, that easy. Now if I want to get a link to it, you can go right here and copy a link to the this repository. Now I'm going to go back to this and Python teaching. I'm going to put the URL in here and hit OK. Oh, contains illegal characters. It doesn't like spaces. And now these should be attached to each other, and I can push that. So now it will connect. Will it ask me to log in? I believe it should. Yeah, log in. And you can log in here. It will take me back to GitHub. Oh, it'll take me to the JetBrains IDE to authorize in GitHub. There we go. Authorize. And since I have my GitHub account attached to my phone, it's going to ask me for a multi-factor. And bing, bang, boom. You are authorized to use GitHub. I'm going to get an email notification too. And now this will push to the master branch and everything will be happy. If we go over here, now we should have a pull request. Oh, or maybe it was just loading. At some point my code will show up in this branch. Uh-oh. Okay, so we had a slight issue there. We now have two different branches, so I need to combine them up. Okay, well, we have the pull request in there. I will deal with that in a little bit. I'll make a separate video for it. I don't want to waste everybody's time. Let's get back to talking about variables. So if you step back 15 minutes ago on this video, you will remember that before we started going through the ins and outs of opening something in PyCharm, we were talking about storing information as blocks of blocks of bits in sort of a continuous reel of tape, and talking about how we need to store different amount of information and deal with it in different ways depending on the type of data that we want to put in there. And I mentioned that Python is dynamically typed. Let's go back to our project. I'm going to make a new file. And we will use it to talk about variables. Come on, there we go. All right, so in order to do that, new Python file, and we're going to name it variables. So we have a new Python file named variables. We're going to add it to the version tracking for GitHub. And I'm going to slightly modify my documentation here. Variables.py shows how to define Python variables. And for future reference, in future teaching bits, I will make sure to do these things beforehand. But since I've not shown, sort of how I go about doing documentation and stuff like that, it's useful for people to see how this kind of works, I think, at least once. So usually, what I do when I write a new piece of, or open a new little script file, is I will start by just having a print statement with just some random text in it, just so that I can make sure that my code will work, that I didn't do anything weird, or there's nothing broken in the file. So in order to test to make sure this code actually works, I'm just going to put print test. I'm going to tell, and you'll see here why using an IDE is nicer than doing this on the command line. We can just go over here and hit run. And it will pop up its little internal console here. It'll tell you what it's running. It even tells you the version of Python it's using to run it. And there's our output. And instead of, immediately closing the command line like we had issues with before, it sits there so you can read through if you have multiple outputs or something. So what I'm going to do now is define our first variable. So Python has a number of types that it recognizes under the hood. It's roughly 20. And those types kind of break down into, in my mind, 3 sets, right? You have numbers, and there are a variety of different kinds of numbers because numbers can occupy different amounts of memory. So we already talked about 0 and 1. This is called a Boolean. It's the smallest sort of memory type for what we pointed out before. It's either a hole or not a hole in the punch card. It's the smallest type of sort of data that you have access to. It's very simple. Sort of the next step up are just simple, small, whole numbers, integers. And what does that mean? It means they don't have a decimal point. It's, 1, 2, 3 countable flat numbers. And because of the way memory is actually stored on modern computers, those have a range of 65, I think it's 65,000 something to negative 65,000. That's because when numbers are stored on the computer, as I pointed out, they take up a little bit less space if you store them as binary and then store them as binary and then sort of put them in memory. When you convert whole numbers to binary, when you get to that 65,000 number, it's where you are going to, it's the largest number you can store before you need an additional binary digit to represent it. So that's, the limit on a basic integer. From there, you get to what's called doubles. Why are they called doubles? Because they have twice the number of binary digits that can allow them to be, or that they can use to store numbers. So you get a much larger number, a much larger maximum that you can store. All that's being handled by Python. You probably won't see any of it. It's pretty good at handling or dealing with various size numbers and not running into issues. But what you will see is the other type of number that Python likes or handles, which is what's called a float. A float is any number that has a decimal point. So the moment you add a decimal point, Python has to deal with the number a little bit differently, and it does that with a floating point, aka it under the hood, Python stores these 8 digits, and it can move the decimal point around, and it doesn't really care where that decimal point is. It cares that it has 8 digits, but it moves that decimal point around, and so therefore it is a floating point number. You can imagine that the fact that there is this floating point in the number kind of changes how it recognizes it in math, because if you want to combine two integers, add 10 and 5, you're never going to create a decimal point. If you multiply two numbers, 5 and 10, you're never going to create a decimal point if you didn't have one initially. If you divide two numbers, you will, in many cases, create a decimal point. So you will need to sort of do an internal conversion from integer to floating point number and change how the stuff is stored under the hood. Python does that for you. This is a really common bug for people to have, in that Python usually ends up assuming that what you want to do is just round, and say you wanted to divide 10 divided by 3, you will need a decimal point to express that. But instead of using that decimal point, what Python will do is say, oh, well, you just want to round your result and continue working in whole numbers. So 10 divided by 3 will evaluate to 3 if you do it that way. We'll see all of this in a moment in code, but I wanted to sort of warn you about what's going on here. So, with that all being said, what did I say here? There's sort of three main kinds of data that you see in Python. Numbers, that's a summary of the sort of numbers that are available. The other one you will see is text, which is extremely important in coding to work and manipulate with text. It almost can't be, the amount of stuff you can do just manipulating text around in code is kind of staggering. You can become like an unbelievably powerful programmer just messing around with text. So we'll get into that a little later, but so that's sort of number two. And then most of the rest of the data types in Python fall into what I would just call lists. There is actually a list data type, but generally it's sort of a group of data that is ordered or not ordered, but a sort of a set of a bunch of different little pieces of data. That third type we're going to spend a long time on in particular, because there's all sorts of complicated behavior that comes out of grouping data together. But for now, for today, we're just going to start with this sort of two simple types. So first thing I'm going to do here in code is I'm going to define my variable. How do we do that? So variables need to be named so that Python knows. I'm going to name this var1, and then how do I tell Python that that's a variable? You have to give it an equals sign. Python, again, goes top to bottom when it's reading code, and left to right. When it gets to this line, it will say print. Also, it'll start reading across here. There's text, doesn't really know what's going on. And then it will get to this parentheses here and say, all right, there's a parentheses here. What is all of this right on here, right, or to the left of this parentheses? Oh, it's print. I know that, the meaning of that. That is one of my functions. So it will say, this is not just random text here. This is a function. And now then it will go and start reading through this parentheses and say, oh, I see there's something. What does print do? It needs some text or something. So this must be the text that it needs. So I am printing this text. The text is test. It will then go down to the next line and it will say, some more random stuff in here. I don't know what any of this means. I am confused. And then it will get to this equal sign and it will say, an equal sign. It's like this parentheses here. It's something special. Okay, so it gets the equal sign and it says, all right, what's everything to the left of this? Oh, well, if it's the equal sign right here, everything to the left of this must be a variable. And it will say, I don't recognize this var1, so this must be a variable definition. And what will it do? It will then look to the right and say, okay, what am I defining this var1 as? And what it will see is the number 1. So it will say, okay, var1 is a variable, and its value is 1. Cool. Python will move on. So now let's see if Python in fact did figure that out. So Python now has stored that there is a variable named var1 and its value is 1. And then we get down to this next print statement. Same thing happens. It doesn't know what's going on until it gets to that parentheses and it says, oh wait, this is a print function. All right, so then what's inside of my parentheses? Well, at first, it's not going to know. It's going to start going through here and say, I don't know what this text means. But once it gets to here, it's going to say, oh, I know this bit of text here. This is var1. That's something that I have stored. var1 is 1. So when we get to the end of this parentheses, it will say, it's var1, it's 1. And then if we save this and then run it, so instead of printing var1, it will print 1. Now, how did Python know that var1 was not just the text var1? Well, if you look at the difference between what we have between these two print statements, it's that little, those little quotations. So if we look now and I print var1, you will see that on that second print statement, it doesn't print the variable's value, it prints that text, and it's because I have those quotations. So clearly there's something going on here as Python's working through code, that certain characters are sort of more important and special, and that brings us to this first sort of note for defining variables, and that is that variable names in general, if you want to be safe, are limited to basic alphabetic letters and numbers. You can put a few different types of special characters in variable names, but for the most part, if you want to be safe, you just limit yourself to letters and numbers, and you can be pretty sure that you'll be fine defining your variables. So if you want to see what I mean there, if I tried to do var, and I wanted to name it var quotation 1, right? That quotation is a special character. Python's going to start stepping through this line, and it's going to say, some random text I don't know. Ooh, quotations. So I'm now going to interpret this as a piece of text. And it's going to say, wait, this is a piece of text, but I don't have quotations to end with. So where do I end this piece of text? And it's just going to bug out. So if we see, boom, let's run this, and we get an error. And it says on line 15, which, look, IDEs are really nice. They give you line numbers, so you know exactly where that is. At line 15, I had an unterminated string. And that's exactly what I had said, was that, it's trying to find this string that you started defining with this quotations, and you never terminated it. You never gave it an ending quotes. So therefore it doesn't know what to do, and it just breaks. So let's instead say I'm going to define var2. So now we have a second variable. We're going to use this equal sign, which is called the assignment operator. It gets a special name in Python. And this time, well, var2, we're going to give it a value of 2. Okay, just keep it simple. And then, so now we have 2 different variables stored. And then, now that you have variables, just like in math, you can do things with them. So let's see what happens. We're going to add another print statement, and we're going to say, all right, Python, you're pretty smart. You know what var1 is, but can you know what var1 plus var2 is? And actually, I'm going to do something. I'm going to make var2 equal to 3, because we'll talk about that in a moment. And there we go. We print this, and we say, look, Python is pretty smart. It knows that 1 and 3 is 4. That's all great. But now what happens if we ask Python, what is var2, so 3 divided, what is var1 divided by var2? So what is 1 divided by 3? Now we know that in math, that's going to give us 1/3. And what is 1/3? It's 0.3333333. Repeated infinitely if we express it in decimals. What will Python do with that? So if we play, this version of Python is smart enough to know that division is going to give us a decimal point, and it has converted this number to a float. We did not run into the issue of rounding that I pointed out earlier. This is somewhat version dependent in Python, and I don't remember when it stops being a problem. But if we ever want to know for sure what's going on, Python gives us some extra tools to do that. So actually, so before I get to that step, let's note one more thing here. So as I defined both of these variables, you can see the IDE is sort of coloring them, and it's showing me that Python's smart enough to know that this var1 equals 1 and this var2 equals 3, and it made those blue because it knows those are numbers. But how does Python in this case know that I don't want to talk about the number 3 as a piece of text? Because sometimes, sometimes 3 is a number, and sometimes 3 is the letter, the alphanumeric character 3 in a piece of text. And you might already know, from the way things have been highlighted and the way I've been dealing with these print statements, that, well, that uses this special character here, the quotation mark. So let's define a var3, another variable, and we're going to make it the text 3. And then we're going to do, just to get ahead of ourselves, var4, which is going to be a string of text. All right. So having both of those there, now you might be able to see where I'm going with this. If we then print var1 and then print var1 plus print var3 and then print var3 plus var4. So var3 is the sort of letter 3, and var3 and var4, we're using the plus sign like we're doing math, but these are strings of text. Now Python will know what to do with these because Python has a sort of operation defined for adding strings of text. And so you'll see that if we do this, we have all of our other print statements coming down here, and then down at the bottom we've printed 3, the text, and then 3 plus text, which then gives us 3 text. That's all great, but what if we try now doing addition, because we have this nice addition operator of var1, which is the number 1, and var3. I actually am not 100% sure if Python will be able to figure this out, but we will find out. So this is what I expected and what I was hoping would happen. So we got an error. Even though var3 is 3 and var1 is 1, var3 is the text 3 and var1 is the number 1. So when we get down here to this print statement, Python comes through here and it says I'm printing something. What's in my thing that I need to print? Oh, it's some math. And what is this math? Well, it's a variable, a number, but and then the addition sign. But then the second part is text, and Python doesn't know how to add numbers to text because it doesn't make any sense. You can't add 5 to apple and evaluate the result. So clearly, even though we're not defining these pieces, these variables as certain types of data, Python is recognizing what types of data they are and figuring it out and doing something with that. And it does actually matter. You can see it says down here in this error, unsupported operands plus sign between int and str, which is string, which is the text in Python. So we have two options. What we can do here is tell Python to interpret these differently. So let's see our two different options. I'm going to comment out this one so that we don't get this error again, which, by the way, if you're ever sort of troubleshooting code, this is the easiest way to go and modify stuff is you're just going to comment out a line and then the compiler skips over it, and you can find your issue and then uncomment it or whatever. So how are we going to do this? We're just going to tell Python what to do with these bits of data to convert them. We have two options. We can tell Python to make variable 1 from a number to a string and add them that way, or we can tell Python to make variable 3 from a string to a number and add them that way. So how do we do that? We go to var1. We say let's make var1 a string. It is this easy. With another built-in function of Python. So this, just like print was a built-in function that we didn't sort of need to define, it's just useful. Python does it for us. str and then parentheses will attempt to convert something to a string. If we want to do the other option of converting var3 to a number, we do the same thing. Int var3. Now what it will do is try to interpret var3 as a number and then add them. And you might start to see our order of operations in math that we have should have learned about is going to comes into play very heavily in programming. Programming follows the same order of operations. So sort of PEMDAS, as they say, parentheses, exponents, multiplication, division, addition, subtraction as order. Programming functions the same way. So it's going to start by the innermost parentheses. It's going to say var1. What are we doing? Oh, we're making var1 into a string. And then we're going to do, we also have these parentheses on the outside, but on the inside of those parentheses, we have addition. So we're going to add those two things together and then evaluate these parentheses, sort of in and out, or sort of in to out on the parentheses. And then we're going to print the result. Same thing here. We have some var3. We're going to convert that to an int first, add those two ints together, and then print the result. And in doing that, we will see we get rid of our error, and we have two new lines here. What are our bottom two lines? Well, the first one is converting everything to strings and then adding the strings. So if 1 is interpreted as text and 3 is interpreted as text, adding them together is going to get 1, 3. So there's that. And our second option here was keeping 1 as a number and converting this text 3 to a number. adding them together, and then you get 1 plus 3 equals 4. So without our help in this case, the Python doesn't know what to do with these types of data, and it fails. We have to help define it. What you can do if you want to be very, very careful in your Python code is you can manually, you can sort of turn Python from a dynamically typed coding language to a static typed, a hard typed coding language by actually enforcing. So if I wanted to define var1, you could see what I could do here is do int var1 and actually force it so that I know that this var1 is actually this integer of 1. That is generally an overkill. It's not considered good practice in Python, but you can do that. Same way with the string, I could just define var3 as str, and I know that that 3 is a string. But Python is smart enough to figure those things out. It's when you get to these math steps that you often have to do these sorts of little modifications to know what you're doing. But what if I am, what if I've done some fancy code stuff and I don't actually know really what data type I'm working with anymore? I'm confused. Well, there is one more Python function that we will introduce here that is essentially just for that purpose. So let's add another print statement, and we will say, what if I don't know what var2 is anymore? All right, I know up here it's an integer, but if I don't know what var2 is, I can just ask Python, what is the type of var2? And Python will tell me. With another little built-in function, it's just type. And, oh, it is a class, which is something we'll talk about a lot later in the semester, but it is a int class. What does that mean? Oh, it's an int. So if you're ever working with your code and you don't exactly remember what your data type is, or actually, here will be a fun thing. Let's use this type function right here to point out something that happened earlier. So let's print the type of that division. So earlier when we divided those two numbers, int, and we added two ints and we got an int out, but then we divided them and Python did something under the hood that was a little bit surprising to me, because I know that it used to struggle with this, but seeing that division sign, it figured out that we wanted a floating point. And just did that by itself. So let's find out what type Python decided that these two variables are. So we're just going to tell it type. And here we go. As you can see, it did, in fact, convert it to a float. So if you then say you needed to divide these two variables, let's say var5 equals those two variables divided. This new var5, Python will figure out on its own via this sort of context that it does, that var5, even though now the right side of your assignment operator is all just math, Python is smart enough to go through this bit of these steps here and say, well, this is an integer. That's an integer from context. And then down here, well, you're doing some operations with variables, but I know that those two variables are integers and you're dividing them, so your result is, just to be safe, it's going to be a float. And in doing all those little steps, Python, in fact, is sort of smart enough to figure out the type of variable that you need to use to do this little bit of math that you needed. It's not always smart enough. This is the downside of a dynamically typed programming language, is that sometimes it's not right. So when you run into problems with your code related to type stuff, they're often really hard to find. It's good to keep it. It's so good to always kind of keep type information in the back of your head when you're working on code in Python, because if you're not thinking about it, it will bite you. It will surprise you. So that's kind of why I make a point to show this so aggressively. All right. All of that being said, that's your introduction to Python variables. We will not talk about the last group of variables that I was pointing out, the lists and sets. Those need their own lecture because they can get very complicated. But that will take you, this is everything you need to know to start working with variables and types in Python. The one last thing I'm going to say before I close out this lecture is, as far as, so this bit of code that you see here, if you turned this in to me for an assignment, you would fail. This is because as far as grading is concerned for like the rest of the course, I pointed out in the syllabus that the majority of your grade is based on commenting. The frequency with which I expect comments is almost line by line. So if you defined a variable 1 here, you're going to say variable used for testing integer math. And variable 3 and 4, variables used for testing string math. And this little print statement here gets its own comment. It'll say testing string versus string versus int addition. And then down here we're going to get testing float conversion. So this is going to seem like an extreme overkill, but essentially this is what I want for all of the assignments that are turned in. Like, I want every sort of little maybe group, sort of maximum of probably 10 lines, every little group of code that you can sort of, the smallest group of code that you can define what its function is. I want you to tell me what its function is. Obviously, at first, this will help you understand what you're doing. Later, this will seem like a really big overkill, but I need you to keep doing it so that I understand that you're not just copying your code from elsewhere. It shows me that you still understand why you're doing setup functions, stuff like that. This is sort of the frequency with which I put these comments in is the minimum. more is better. I'm never going to deduct points for having too many comments in your code. If you wanted to do every single line, you could.